Alright guys, welcome. So we're going to try something just a little bit different here this time around for our learning of constructive and destructive waves. So basically when we're looking at this, it's kind of important to note, I want you to be able to add and subtract how the wave goes together using terms constructive and destructive. So it's important to be able to use that vocabulary, understand how these add together, how they subtract together, and what we get. And what you're going to notice here is here's the links to constructive and destructive that we've already kind of shown and went through. If you want to watch them again, you can. They're a great example of how my constructive wave is going to add together, which if we had to choose between these two, we would probably choose this one. Coming together, these two, the blue and the red waves, add together and create a larger amplitude at the point where they intersect. Okay. Whereas when we get to a destructive wave, we have our two waves going in opposite direct or inverted from each other. One's above, one's below, and we can see is that we have in the middle where they meet, the green line there is formed, and that is a 0 point. So where they meet, they interfere, and this is a destructive interference. Okay, so these are kind of the learning target, is to be able to compare and contrast these two. So let's move forward. One of the key important ideas is this thought process of the law. I'm going to move my face out of the way so you can get this displacement. Is the principle of superposition. Okay, and basically the thought process here is behind the principle of superposition is when two waves interfere, the resulting displacement of the medium, so what happens when they interfere at any location, can be basically the sum of the displacements at that spot. So in more words or less, I'm one box up with the red here wave, and I'm two boxes below for the blue wave. And when these two waves interfere and they hit each other, the red and the blue will subtract, and we will result in the green. So we got one positive, two negative, we get a -1 green as our result at that position. That is our superposition result. That's what principle of superposition means. So here's some examples down below here. If I have a displacement pulse, my first pulse is always the red, my second pulse is always the blue. And what we will see is when we add 1 and 1 together, we're going to get 2. And when we have -1, -1, we're going to get -2. And you can kind of see this thought process here of our resultant displacement. When the two waves either constructively or destructively interfere with each other, they're going to constructively add to each other, destructively subtract from each other. So what I would like for you to... So here's even a better example of that, and I'll get this... Here, I'll float up here now to be out of our way. We can see that we have... Oops, sorry. We have the blue wave and the red wave together. And we'll notice that their crests line up as well as their troughs line up. So over here in the wave over here, we're going to have a very constructive thought process here where these waves are going to add together. And so you notice I'm up 1, 2 boxes here in the middle at the letter K, and 1, 2, I'm up 4 boxes at the letter K for this blue wave at that specific location. What I have over here to our right is the green resultant wave. So this wave is going to, the 2 plus the 4 is actually going to give us 2 more up, and that's going to be 6. So we can see how this wave is adding to itself constructively. Okay, the peaks are lining up and creating even larger amplitude peaks. Okay, so these, obviously this is an example of constructive wave interference. Let's move on to destructive wave interference. I'll get my face out of the way again, and we can see that along this medium, for example, at these different points, there are going to be times where it's constructive and times where we're going to see a destructive value. So there's different times along this where we're going to be destructive. For example, if I'm looking at letter O here, I just scanning through this, I can see that this peak is on the opposite side of this peak. These two are going to subtract away from each other. Okay, so what I would like for you to do is practice this wave right now, adding the resultant to your notes. So you probably want to show both waves and then the resultant as well. And I would like for you to include 3 examples of a constructive waves, adding to each other, subtracting from each other, where you're going to see a little bit more complicated example like this, okay, where you can actually identify what the result is. So we're going to see, even at these middle parts here, there isn't going to be, these are really adding together because they line up there. They're still going to be at 0. So I'm looking for you to kind of get some practice and better understanding of drawing how the positive 2 and the negative 3 here would line up and create that new wave at that amplitude spot. And you know, just another example of this negative 1.5 and positive 1, 2, 3, 4 lining up and creating that next spot. So I'm going to take a little bit of time now, compare and contrast this superposition idea with the positive constructive interferences and the negative deconstructive interferences. Pause the video, do that for me please in your notes, take a little bit of time to understand it and process it, and we will come back in a little bit. Okay, so after you got a little bit of practice, you should have seen that at these locations, for example, G, J, M, and N, these were all points where they lined up together, the peaks lined up together, and were a constructive interference. Whereas also we had some destructive interferences in this wave as well. This is a really good practice opportunity for you guys. A great spot for you to check your understanding. Hopefully you have a better understanding with the notes you added as well of how they constructively and destructively add. So where do we see this in the world? And the answer to that is, well, noise canceling headphones. Now there are 2 types of noise canceling headphones, active and passive. And what I'm going to ask you to do is read on in this a little bit more after I explain it here. But passive noise canceling headphones, basically they just give lots of padding, or they get really good ways to not let sound into your headphones. This is, you know, a good way to not really hear what's going on. They basically just passively do this. They don't really use energy. They don't use any technology to try to cancel out the noises that you hear. They are just hoping that they're kind of keeping the sound out from getting into your ears. The other more interesting in the science nerd world would be active noise canceling headphones, where they actually are using sound waves. So what the basic idea is, and I'll ask you to read over the how stuff works here in a little second to kind of get better, deeper understanding, is we have an initial frequency and amplitude of the noise that's coming towards our ear. And what noise canceling headphones do is they actually generate the same type of wave but inverted. So it has the same frequency, it has the same amplitude, and since it's inverted, these crests cancel out and we basically don't get any sound in our ears. Okay, it's the exact idea that we're talking about. So I want you to pause the video here for a couple minutes, and I want you to check out the How Stuff Works link. It's going to take you to the one page that really kind of dives in a little bit more as far as how that works. So you're going to see some cool little pictures that you can add to your notes to help you understand this real-life application. Okay, so take a minute, pause, read over this link, and then start back up when you're done, when you've added some more. Okay, like I said, this is really cool stuff, and I'll just walk you through what you read here in a little bit just to make sure you get all clear here. But basically, the sound wave that are external that we hear from our ear, like I kind of explained already, has this look to it. And the speaker itself generates one that's just kind of inverted. When you add these two together, they're going to cancel each other out. The crests line up inverted from each other, so there's going to be a deconstructive wave interference, and that is going to equal silence. So you have the microphone listening to what is externally created. A circuitry does the inverted 180 degree out of phase associated with, so it just moves it over, and these will subtract away from each other, creating our silence. So kind of a cool application to what we're actually learning about here. So moving back to another option of real life examples would be light or water. And this is also pretty cool in my opinion. So I'll explain this first and then you should watch the video. So basically we have our initial wave coming out, and light can act as a wave particle at times or a particle as well at times, depending on the scenario. It's kind of complicated stuff. We'll get more into that as we talk about light in our next unit, but for right now we're okay. So basically we have two waves happening here. Going through each of these slits, the light is acting as a wave. And so this wave is propagating a wave out from it in a circular pattern. This would keep on going around and around and around. And the video does a really nice job of showing that initial wave. Okay, just back and forth, just a rippling effect, circular, going around and around, out from the middle where we're causing that disturbance to occur. And so then we have this second wave occur, and what you start seeing is where the wave is interfering constructively and destructively. Okay, so these parts where it's constructive and destructive start creating this pattern of light and dark bands. And that can be seen in light as well as the water that we're going to look at here in a second. So when I'm looking at my dark spots, that is where light subtracted from each other, acted destructively. Okay, the waves amplitudes didn't line up exactly, they subtracted away. There's not much light there, if at any. Where I start seeing my light band patterns is where they added together. Let me show you the example on the... Okay, so what he's showing you here is this. Basically, we can see these waves interacting with each other and constructive and destructive interference. Now, what you can see is this, and what he explains is constructive. Parts where these waves amplitudes get larger, and that would be these locations right here. In the middle where we're seeing these larger ripples. Where the destructive points happen is these dark little alleys, okay? And that is where they're breaking each other apart, and there's no wave there at all. It looks almost flat, like a flat surface in the water. This is an example of how we did it on waves as far as light as well as here on the water. Okay, so I think the video does a really nice job explaining that for us as well. So when we're at the point here in our video where we've already described this, and I want you to add this into your notes, some examples of this thought process of how light and water can be constructive and destructive wave interferences. I want you to now summarize constructive and destructive interferences using our vocab word of principle of superposition. I would like for you to create 2 level 2 questions and then answer them, as well as summarize the main ideas with 3 sentences. Include a picture, include the real life examples of where this occurs, have a nice deep understanding of this. Now, and when you're all done with that, I'll ask that you head towards the worksheet, which is on this slide right here, slide 98. The worksheet's right here, digital copy. I have a paper copy for you as well to work on. I have the answer key for you as well. I would also like for you to make sure you highlight additional examples of where we're adding and subtracting actual values on a constructive and destructive wave and getting a resultant value. Alright, well, thanks for watching the video. I hope this made a lot of sense, and keep on learning. I appreciate it.